All right, welcome back, guys. So in this video, I'm gonna briefly introduce the constant E and continuous. So 3.1, the title is introducing E, and what is continuous compound interest rate. Okay. So then in the next couple lessons, we're going to look at application of exponential function. And the exponential function we focus on with the base is e quite often in this class. So I just want to take a minute just introduce what is e. We heard that number quite a bit, and how do we use what we learned so far in the previous lesson, which was limit. That was the beginning of this class, the concept limit, to kind of tie that to the constant e. So let's just start out by looking at the just the recall the formula of just compound interest formula. And so this formula will tell us the amount in the account with certain initial investments and certain rate of interest, and after a certain amount of years you can calculate how much is in the account. So it start with A as the future value, P is the present value or the initial amount or the principal, times 1 plus R over M to the powers M times T, right? So R is the interest rate, and M is the number of, so P is principal, and then R is interest rate. And this is usually the annual interest rate. And then M is the number of compounded period. In a year, right? And T is in years. Now, there's another formula we can use in this lesson, is that when we start applying the interest, the compounded interest rate to the principal, not monthly, not daily, not hourly, but continuously. Okay, if we apply, So if we apply, if we say that, if we apply the compounded interest continuously, meaning every moment, then this formula here now becomes principal times E to the RT. Okay, so this first formula is compound interest formula. The second formula, this formula here, this here is the continuous compound interest formula. Okay, all right. This is when you apply the compound interest to the principal at certain annual interest rate over and over again, every moment of second, or even not even a second, just continuously. That's the mathematical term that we use in there. All right. So let's discuss what is E. What's the value of E? Okay. So if we take the limit, okay, definition. So definition. Okay, the number E. Okay, if we take the limit as n goes to infinity of this expression here, 1 plus 1 over n to the power of n. If we do this, if we apply the limit as n go to infinity, this expression will approaches the number E, which is around 2.712281828 So this number E is kind of like pi. It's an irrational number, non-terminating, non-repeating decimal. And we can see how this. So let me just show you. Let me just plug a few numbers here, so we can actually see this here. We can say, okay, well, here's n. Here's my 1 plus 1 over n to the n. Let's just use a table to kind of show that you can see the patterns of the values of this 1 plus 1 over n to the power of n approaching the value E there. So let's start with 1,000 for n, and then maybe go to 10,000 and go to a million. And you can see that this number will approach e. Okay, let's go to the calculator. So we have 1 plus 1 over n. Let's use n to be 1,000. Okay, and then we'll raise this to n. In this case, it's gonna be 1,000, right? So you can see, so when n is 1,000, is 2.7169233932. Let's try. Oh, I don't know what happened there. Let's try. Okay, I don't know what happened. Let's just go ahead and exit that out. Okay, now let's try with 10,000. Okay, raise to the 10,000. And you see, so the number now become 2.71814. Let's try one more. 1 million. When n is 1 million. All right. Again, let's get very close to 2.7182804. So eventually, this number will approach this number, what we call here is e. Okay. So that's one way to get the limit, the constant e, by taking the limit of this expression here. Okay. Another way is through compound interest formula. Okay. So here's the formula. Okay. Suppose your investment is $1. Okay. And you are investing at whatever this thing that you invest in is, you're investing it with the annual interest rate of 100%, which is going to be 1. And you are compounding it. The compound period is going to be continuously. Okay. And then t is going to be 1 year. Okay. So it turns out that the amount in the account at the end of the year is E, $2 and around 72 cents. Okay. If we rewrite this here, we say A equal to P times 1 plus R over M MT. If P is 1 and R is 100%, so that means it's 1. And then T is going to be 1 because it's after first year. And what does it mean to let M to be compounded continuously? That just, so we say compounded continuously. It just means that we take the limit of this quotient, this P, times 1 plus R over M to NT. We're just taking that limit and let n go to infinity. Okay? By plugging those numbers P, R, and T, all those can be 1. Now this become limit as m go to infinity. This is 1, and then R is 1, is m, and then T is also 1. So it is going to be E as well. So that's just the same expression there. Okay. All right. So that's how you can think of where's E come from. One way to think about where E come from is just doing investment compound interest, but continuously with the $1, and then invest at 100%, and then at the end of the year you have about $E in your account, which is about $2.72. Okay. So that's E. Let's do some example where we have an application that deal with compounded continuous investment. Okay, so here's an example. Okay, so this saying that how many years, we want to find how many years will take initial investment of 5,000 to grow into 75,000 if it is invested at 8% compounded semi-annually and then compounded monthly. I'm going to go ahead and change this to continuously. So I'm going to go ahead and cross this out. Okay. continuously. I can't even spell this. Okay. All right. So how many years? Well, if it's compounded continuously, the formula is A equal to P times E to the RT, right? The principal in this case is 5,000. That's the amount that we start with. The interest rate is 8%, so the 0.08. Okay. And we want to find, T, because how many? You find T such that the value in the account, we call that A of T, is 75,000. Okay, so we know what A is, so that's gonna be 75,000. Excuse me, 7,500, not 75,000. And we know what P is the initial investments or the principal, which is 5,000, times E. R is 0.08, and then now we're supposed to solve for T. Okay, so the first thing first is you want to get rid of the constant in front of E by divide by 5,000 both sides. So 75 divided by 5 is 15 for the left hand side. Actually no, 7,500 divided by 5,000. It is 1.5, so that's wrong there. This should be 1.5. And then E to the power 0.08 T. So in algebra, we learn how to solve exponential equation that has an E base. So we learned that we're allowed to take the natural log both sides, so that way the natural log, the E, cancel each other out. So we're going to say the natural log of both sides and then when you take the natural log or log of any base, one of the properties of logarithm is you can bring down the power to the front. Okay. So this is where natural log and E cancel out here. So natural log, when you have a log of base E, by definition, this is natural log of x. Okay. So when you have ln of E, that's just log base E of E. So by definition of logarithm, this saying that what power such that E raised to get E, so that's going to be 1, the power of 1. So in this case, it's going to be 1. Okay, so we have ln of 1.5 equal to 0.08 T. Divide both sides by 0.08. So we have ln of 1.5 divided by 0.08. So that would give us 5.07 years. So it takes about 5.7 years for a 5,000 to grow into 7,500 if it's invested at 8% compounded continuously.